All right. To show that a conjecture is true for all cases, you have to prove it. And I've mentioned that a couple of times. That's why I keep writing it seems, because we actually haven't proven things. But it is something you're going to learn to do. The nice part is to prove something is false, it only takes one example. So proving something is true is a lot of work. Proving something false just takes one counterexample. So, and that's the big thing here is we got to learn how to use counterexamples. It can be a specific number or drawing or some sort of statement, and it just shows whatever your conjecture is being false. Now, example 4, find counterexamples. So we're going to find a counterexample to show each conjecture is false. If n is a real number, then n squared is greater than n. Well, let's take some real numbers. I know a couple. How about 2, 5, and let's do negative 10. We'll start there. So the whole idea is 2 squared greater than 2? Well, yeah, 4 is bigger than 2. That one checks out. Is 5 squared greater than 5? Yes, that checks out. 25 is bigger than 5, right? Negative 10 squared greater than 10, negative 10. And yes, 100 is definitely bigger than negative 10. So that one checks out too. So far, all of these examples I've looked for haven't disproven the conjecture. They've all just confirmed it. But they told me that there is supposed to be one, so there's got to be something out there. So you got to think about, what else do I know about real numbers? Well, they can be fractions. Let's try a fraction. How about 1/2? What's 1/2 squared, and is it bigger than 1/2? Well, 1/2 is 1/4, and is 1/4 bigger than 1/2? No, it is not. So there's my counterexample. I'm going to give myself a little bit more space here. Counter example. N equals 1/2. Now 1/2 is a real number, and I'm going to write down that 1/2 squared is actually less than 1/2. So you can see, because I have changed the direction of that inequality symbol, I've shown that what I claimed before is not true anymore. All right. So I only needed to find one. I looked at 3 that worked. That wasn't good to actually prove it's true, because I found one number where it didn't work, and then I broke it. So, next one. If jk equals kl, then k is the midpoint. So if I've got a line, and I got j and l, and I got, let's say jk is 5, and kl would also have to be 5, because their measures have to be equal, then it seems like, yeah, k should be the midpoint, right? So what would make k not the midpoint? What if it wasn't collinear? Right now they're collinear. If I draw something that shows that j and l are not collinear with k, maybe that works. Well, let's say jk here, let's say it's 6 long now. That means this also has to be 6. So I still meet the first part of the conjecture. jk and kl are equal to each other. But because I pulled k off the line and was still able to make that first part true, k is not the midpoint anymore. So, counter example. jkl is not collinear. And with this, I'm going to include the picture Just like before on the last part of it, I included the little example of 1/2 squared is less than 1/2 to show it. That's kind of like, you just don't want to say what the example is. Show me what the one example is. You only have to find one of them so you can show it to me.